So these systems of linear equations can be used to solve a variety type of problem, and we can use them in economics to solve problems involving supply and demand. We're going to do that in the next page, and we can use them to solve problems where there's more than one variable, such as this problem over here, where we're dealing with a mixture of caramel corn with honey roasted nuts. So in these problems, it's helpful to make a diagram. So that's what I'm going to do first. I'm going to make a diagram. And these little boxes are going to represent what I'm going to mix. So in one of them, I'm going to be mixing caramel corn, and I'm going to be adding it to the honey roasted mixed nuts. So honey roasted mixed nuts. And at the end, I'm going to end up with some sort of a mix. Now, I'm going to basically label each one of these containers with some information. So on the container itself, I'm going to write down how much money is worth. And on the bottom, I'm going to write down how much of the stuff I have, how many pounds. So for instance, the caramel corn in this problem is worth $2.50 per pound. It's being mixed with the honey roasted mixed nuts, which is worth $7.50. And finally, I want to sell it as a mixture at $4.50 per pound. Now, I want to make 20 pounds of the mix. And the question is, how many pounds of each one of those things should I mix together to produce the 20 pounds? Now, to get the setup going in these problems, we're going to build two equations. One equation is going to represent how much pounds I'm using on the left and on the right. I'm mixing X pounds with Y pounds to produce 20 pounds. So the X and Y could be 1 and 19, it could be 10 and 10, it could be 0 and 20, I don't know. But I know that the two poundages have to add up to 20. Okay, now the other equation that I'm going to build is going to be responsible to determine the value, how much money I'm putting into my mix. So on one hand, one of the first mix is going to be $2.50 per pound, and I don't know how many pounds. The second unit in the mix is going to be $7.50 per pound, and I don't know how many pounds I'm using, but I want to sell it at $4.50. And I know I want to sell 20 pounds. So that's basically called the money equation. So one equation represents the pounds and the other one represents the value or the money. And so now I'm going to rewrite the problem one more time to make it look a little bit better. So x plus y is equal to 20. And then 2.5x plus 7.5y is going to be equal to 20 times 450, which is going to be at the end 90. Or rather 9 and 0. Okay, so now we can decide whether we're going to solve this problem using elimination or substitution. It's up to you, whatever, doesn't matter really, just pick one. In this problem, the x turns out to be 12 and the y turns out to be equal to 8. So what does that mean? That means we need to mix 12 pounds of the caramel corn with 8 pounds of the honey roasted mixed nuts. That's basically how the problem is going to end. I didn't show the details on how to solve the system, but I'm pretty confident that you know how to solve the system now. You can either do it by graphing or by elimination or substitution. Just use one of those methods to get from this system to the 12 and the 8 solutions.